We'll be going over the 3-axis milling package today, and that includes mill 3-axis standard, mill 3-axis pro, and mill 3-axis premium. You can see I'm just working on this basic part file today, and we're just mainly going to be focused on this surface here. Well, we're going to be roughing and then finishing on a single surface like this, and then finishing around the whole part. That's what we've got all these features here for. So I will start from the beginning just to show you the basic workflow in programming for milling here. I go to the top and go to CAM, this tab over here on the right. I go to a new job, the first option right here, and I select my milling job type and what milling machine that I'm using here. If you don't find your specific machine here, you can find it. You could start by looking under bobcatsupport.com, and there is a section for post processors. You can look for your specific machine by downloading a post processor there. And if we don't have your machine in that extensive library, again, you can contact support and we'd be able to make the post processor if you need us to, or if we don't have it already, or we can send you one that we already have. Maybe need to modify it. You can send us a sample program of how it needs to be output, and then we can create that post processor for your exact specifications. All right, so I'm just going to go with the BC3X mill. In here, that stands for the Bobcat 3-axis milling machine. I go to my stock wizard, select my workpiece where I'm selecting my 3D model here. That can be helpful in simulation where I can see and make sure that everything is cut to size. If I don't have a 3D model, I can just skip this page by going to the next arrow button here. We have our stock definition page. So I can type in the parameters for my stock. I can select rectangular, cylindrical, whatever shape it is if you want to extrude it from wireframe, or select a solid model. So if you're working off of a casting, for example, you can define it here and avoid any air cutting by defining your stock. And then the last page here is the machine setup. This is where you're setting your work offset, G54 location. You would click on the coordinate system here, the origin location. Let's say you're touching off at this location, the bottom left corner of your stock. You can click on that corner, or if you need to flip it over to do some milling operations, you can rotate it around. Click on origin, click on your origin point, click on X direction, click on a point or a line going in that direction here. And you can also reverse the directions with this arrow button next to each one, so that your Z-axis is pointed up, and now you can do some milling operations on this side. So I'm going to just cancel out of this because I have my own milling job up above it here. So we'll expand those options here. We have our machine, post processor, we have workpiece, stock, and machine setup. And so I'm going to right click on machine setup 1, and here's where all of our milling operations are located. You can see our drilling, tapping, counterbore operations, 2-axis milling operations. And if you guys are familiar with 3-axis, I'm sure you guys are familiar with the 2-axis milling operations here. 2.5-axis machining, which include a profile roughing operation, profile finish, pocket, facing, engraving, chamfer mill, and corner rounding operations for our 2.5-axis milling operations there. And we'll get into 3-axis milling. You can see when we get into the milling operations, now everything is docked to the side here of the software program. That is a new feature in version 38. I think not 2 weeks ago, but 4 weeks ago, I did a webinar on what's new in version 38. So that's a great webinar to view as well, to see all the new features, like how to navigate this new interface here for CAM and some other neat features that are in the newest version of Bobcat. So we're here in the mill 3-axis. So when I right click on machine setup 1, we go to mill 3-axis, and we're on our first page here. We're setting the top of feature, which is going to be at Z0 here, our rapid plane, feed plane. Next page, we have all of our available operations. So we'll go through them here. Our first 6 operations here are in the mill 3-axis standard, and the ones below that are the mill 3-axis pro. And then we'll get into the mill 3-axis premium later on. So the first 6 here, Z-level rough, Z-level finish, following along any curved surfaces, planar, going back and forth across the surfaces here, spiral, just starting from the center and spiraling out, radial, which is starting from the center and going to the outside edges and coming back to the inside, this radial option, and then a plunge rough option where you can plunge the end mill down to rough it out. After that, you have all of your mill 3-axis pro operations, starting with an advanced rough. So just like in the standard, we have a standard rough. In the pro, we have an advanced rough. In the standard, we have Z-level finish. In the pro, we have advanced Z-level finish. In the standard, we have planar. In the pro, we have advanced planar. We have some other 3-axis finish operations in the pro, including flatlands, which will detect all of the flat areas and mill those out with a flat end mill. Equidistant, sort of the spiral toolpath. We're starting at the outside of the boundary here and offsetting to the center, or you could start from the center out. And it will create toolpath based on the boundary. So it will create equally distanced step over from the center out, giving us a better surface finish. Pencil to mill any fillets. Project curves, where I can project a 2D shape onto a 3D surface to do a 3D engraving operation. And steep shallow is a newer one. I think that started in either 36 or 37. And what this will do is basically 2-in-1. Your Z-level finish will follow along any curved surfaces like this or any tapered walls, and it will include a planar toolpath or an equidistant toolpath on any of these flat areas here. So that way you don't have to do a Z-level finish and then come back with a planar toolpath. It does it all in one. So we're going to take a look at the 3-axis roughing in the standard options, and then the options in the Pro toolpath for 3-axis rough. And we go to our next page where we set up our work offset number. Next page, we're setting up our tool. So I can go to the tool crib, and we have our tool crib up at the top, tool library down at the bottom where I can load tools in and select them for the roughing and the finish here. Set my spindle RPM, cutting feed rate, plunge feed rate down at the bottom of the tool page for every operation. And we'll get into some of the options here in the 3-axis standard. So options for the cut pattern, we have pocket in, which will start from the center, work our way out. Or pocket out, we'll start from the outside and work its, I reversed those. Pocket in, we'll start from the outer walls of the pocket and work its way in. Pocket out, we'll start from the center and work its way out. Then we can set the option for climb mill or conventional milling. Set our depth of cut here. Let's go 1/4 inch depth of cut. If in case you ever run into these sort of pop-up windows, I guess you could call them, there's an option to turn those off, which is right down here at the bottom. Looks like a person with a dialog box. It says enable disable contextual help down at the bottom right. So I can turn that off so that it doesn't mess with the numbers. So we've got our depth of cut of 1/4 inch. Step over, we'll go 300. We can set an allowance, so we're leaving a certain amount of material for the finish pass to clean up. And our last option here is top of job and bottom of job. And I'm going to close out of this for a second so that we can take a look at what that option is for. So the standard toolpath here, if I take a look at the top view, We can set our geometry that we're roughing. We're roughing the whole 3D model here. So I selected the 3D model as our geometry. And then we can contain the toolpath inside of a boundary. Now the boundary would be a 2D sketch, and we would be containing the toolpath inside of a 2D area like this. Maybe if I just want to cut the left side of this part, I can create a rectangle around this area to make as a boundary. And it will eliminate all of the toolpath over on the right-hand side here. Then, if we want to contain the toolpath at a Z depth, that's what our top of job and bottom of job here are for. So if I click on that, you can see if the top radius is already cut to size, I can start the toolpath here by just typing in a depth. That's where I'm starting for top of job. And if this bottom radius has already been cut to size, I can end the operation here with the bottom of job depth. So we do have some options in the 3-axis standard, just some basic options. If I want to plunge, ramp in, spiral into the material, entering into the stock. Some options by level, how I want to cut it, if there's multiple pockets, if I want to go at a certain depth, or if I want to cut out one pocket first and go over to the next, which would be by area, or by level of Z depth, which would go back and forth. We have our advanced feed rates in the standard. If I'm not able to set a rapid rate at the controller, I can set my rapid moves to feed moves and set that rate here. And last page is MDI. That stands for manual direct input. If I wanted to add any commands before or after the operation here, I can type in any commands in the task list here. So if I want to type in like an M01 command after the operation, I can do that here. Next, we get to our 3-axis roughing pro operation, or this is the advanced rough. We have a couple options here, the standard UI or advanced UI. Now, UI stands for user interface. We're going to stick with the standard UI first, and then we'll come back and look at the advanced user interface here. So the standard UI is just basically all the pages that we just went through. The tool page, then we get to the cut pattern. Again, we have our offset out and offset in. We have a couple more options for pocketing in the advanced rough, like the parallel, which will just zigzag back and forth across the stock. Morph spiral would start at the center and spiral its way out. And the morph spiral and adaptive roughing, these are both high-speed machining operations. So we're starting at the stock, and we're sort of zigzag back and forth like this, you could say. This is called tricoidal milling in the adaptive roughing. So you can see if this is one directional cutting, it'll get to the end here, retract just a fraction of an amount, and then wrap it to the next location, and then keep going like that. Or we can zigzag back and forth like this. There we go. All right. What else do we have? Same options as before, depth of cut, step over, top of job, bottom of job, setting our allowance for a certain amount of material for the finished pass to clean up. We have plunge, ramp, spiral down into the material, entering into the stock. Now with this tool path, you can kind of see it here. Where the tool is starting here and entering into the stock like this. So instead of plunging down into the stock, I can turn off center cutting tool here. There we go. You can see the first move right here is going to plunge down, and then it's going to enter into the stock outside of the stock. So this is our side roughing option, where we're just using the side of the tool. We're not plunging the tool down in, ramping or anything like that. We're starting from the outside. We're plunging down from the outside of the stock, and then we're coming in with the side of the tool. That is offered in the 3-axis Pro. Same with the tricoidal high-speed machining options. Pro also offers a couple other options here on the next page. Rest machining. So if there was a previous tool, I think I'm using, basically using a 3/4 inch tool here. And if, for example, I was using a 1-inch tool before this, I can check this box, tell the software I used a 1-inch tool. The software will calculate any areas the previous tool couldn't fit into and calculate just that toolpath. So essentially, it will start right where we left off from the previous operation and avoid any air cutting. We also have machine flatlands. So if there were any flat areas on the part, we could come back with an additional pass and clean up those areas on the flats there. Next, we have linking for each step over. Our gouge check page that we have in Pro. So if it was gouging in the workpiece here with the tool or the tool holder, I can check the surfaces here. I could also load in my fixture and make sure the tool avoids that as well. Advanced feed rates, we have a couple more options here than just the convert rapid moves to feed moves. We have linking feed rate, so where it's linking between groups of geometry, we can speed up that process. And we also have adaptive feed rates. So when the tool is getting into larger material, like into these corners, the software can calculate how slow the tool needs to move to keep a constant chip load. And that can reduce chattering at the machine. And our last page is MDI. And we'll hit finish on this one. Didn't make any more changes there. Next, we'll go to, that's about it with the standard and the Pro operations. Again, we'll go to the Pro here, backplot it, and we can see the side roughing option. Oh, let's turn on the stock here so that we can see that better. So the backplot, in case you don't know where that is, you can right-click on any operation here. So I'm right-clicking on 3-axis Pro, or I'm right-clicking on the advanced rough and going to backplot. And I can see the tool location is going to go down to that depth, and then it's going to enter into the stock with the side of the tool there. Give you a better visual of that. All right, so that's the 3-axis standard versus the 3-axis Pro. It offers the side roughing option like this. It offers the tricoidal milling, high-speed machining options. If you guys are familiar with Mastercam, you will be familiar with dynamic machining or dynamic roughing. That's the same kind of operation as our adaptive roughing in the Pro. And we've got some other options like the rest machining option and machine flatlands to finish up the flat areas in our roughing operation so we don't have to come back with a flatlands operation. Let me know if you guys have any questions so far. We'll be getting into some of the 3-axis standard versus 3-axis Pro finish operations. And then we'll get into the premium toolpaths, which are finish operations only. There's not really any roughing operations there. And the premium is a surface-based toolpath. So you're selecting specific surfaces, and it will create toolpath right along the specific geometry. So if you have any irregular shapes, sort of like the one that I have right here on this surface, it can be really good for a premium surface-based toolpath. So yeah, let me know if you guys have any questions in the comments section. We'll keep moving forward here, if not. All right, we'll close out of the back plot. We'll collapse this option here, and we'll go to the single surface standard. So we're just focusing on this single surface here in the finish operations to begin with. We're looking at the Z-level finish operation. So that'll follow along a curved surface like this pretty well. The planar toolpath, you can see the step over, and the linking is a lot nicer than the Z-level finish on this one. It tries to sweep around like that, and that's some additional movement there that's not really necessary. The planar toolpath is pretty good for that. But even with the planar toolpath, if we look at it from a top view, it's going back and forth like this. It doesn't follow the curvature of the shape, so you can see the step over is kind of weird right here. Kind of hard to see with this pink toolpath, so let's see. There we go. It's better in blue. You can see the step over like this. Much larger step over than when we get up here. All right. That's again good with the premium toolpath that we're going to get into later. Looking at the spiral toolpath, and so spiral toolpath starts from the center, spiral its way out with a ball end mill, and also we have a radial toolpath, which starts at the center and then keeps going around. Again, you can see since there's such an irregular shape here, it's sort of doing this weird dogleg kind of move here as it goes around. So we'll look at the 3-axis standard operations here, and then take a look at, so that was with the single surfaces. Z-level finish, where we have a ball end mill. We set a depth of cut. We set an allowance. It's going to be 0 because this is a finish operation. Top of job, bottom of job. Our entry move, if we want to set a lead in and lead out. Options, linking, advanced feed rates, and MDI. We have our planar toolpath, where we're using the same ball end mill. Zigzag cut pattern, and this lace angle direction is the option here to go 0 degrees. Will go back and forth along the x-axis like this. If I set it to 90 here, it'll go back and forth along the y-axis, up and down the surface. And I can do anything between 0 and 360. If I need to do a 45-degree angle cut, I can set it to 45, and it'll sort of go diagonal like this across it. All right. Entry option for the planar toolpath, linking, advanced feed rates, and MDI, which are going to be the same on every 3-axis toolpath there. We set up our tool for the spiral toolpath. We can set a step over on this one. This one's not really a great surface to work on with spiral. We're going to be doing the whole part surface finishing, which the spiral could be pretty good with, or maybe like on the top surface here, if we need to spiral around that would be a decent surface to pick. Entry options, linking, advanced feed rates, MDI, and then we get to our radial toolpath for the single surface. And same options as before there. So that was for the one single surface. The geometry selection was just the single surface here. But again, if I want to cut the toolpath down, like with the Z-level finish, and this one actually is sweeping pretty well in that area. Z-level finish, planar, or maybe like the spiral toolpath. You can see like it dips down past the bottom here. I can right-click on boundary, reselect. I can select a 2D shape, any kind of sketch, or I can click on these edges of the surface, and it will contain that toolpath inside of just this area here that's highlighted. So if I click OK, right-click on the spiral and compute, you'll see that toolpath be cut down so that it follows right along the surface there. The spiral actually looks a little bit better, but I don't know if you'd want to spiral around the surface. Usually you get the best finish just going back and forth like this. But yeah, that's how you can cut down the toolpath in the 3-axis milling. Use a boundary to contain the toolpath inside of that area so that it cuts that down there. Okay, so that's the single surface. If I want to do the whole part file, again, for my geometry, just select the 3D model. And we're back into the Z-level finish. So you can see how well even the 3-axis standard milling operations do with a finish operation around a 3D model like this. It just starts from the top here, right-click and backplot. Just starts from the top and works its way around the surfaces based on the depth of cut that I've set in the Z-level finish. Next, you have your planar toolpath. This one's decent, but again, you can see this step over, if you can see it here in blue. Very large step over from where my cursor is from here to here. But then when we get to the top, the step over is, from here to here. And that's because of the geometry of the 3D model and the way the tool is shaped with the ball end mill. It does a larger step over across here, but when it gets into the nicer surfaces, the flat surface on top, it does a basic step over there. It looks a little bit nicer. So we'll collapse that one. We'll get into the 3-axis Pro to follow along the single surface here. And then the 3-axis Pro to follow along the 3D model. So the best one in the single surface and standard, I would say probably would be either the planar looks decent. The spiral actually looks pretty good with the boundary, but I would rather just go back and forth along the surface here. But again, you can see like the larger step over, the spiral toolpath gets kind of weird up at the top here. The 3-axis Pro, we have an equidistant, and this is a really good toolpath, I think, where it bases it off of the geometry that I have of my surface that I've selected. So you can see it starts from the outside in this example, the outside boundary, and then it creates an equally distant step over from the edges inward into the center of the surface. So you get an equally distanced pass every step of the way there. In the equidistant, you have the setting to step over, or you can spiral into the center of the surface. And you also have your option of sorting. We just did standard, and it usually starts from the outside to the center. I can start from the center and work my way out and take a look at how that looks too. So this one starts at the center here and then works its way out until it gets to the outside edges. And again, you can see the toolpath right here from the boundary. Again, it creates an equally distanced step over into the center of the surface there. David asked, is the boundary the edge of the tool or the center of the tool? Good question. It is the center of the tool. And you have that option in all of your 3-axis Pro milling operations. You can set that option too. That is under options. And you can see here tool tip location. So normally it's center of tool, or you could extend it out to tool outside. So the edge of the tool will, or I guess you could say the radius of the tool will offset to the outside of the boundary. Or you have tool inside, where the edge of the tool will stay inside of the boundary. But normally it is set to center of tool. The center of the tool will end right along the edges that you've selected as your boundary. Good question. All right. Next, so we went through equidistant. We have, what were these other ones here? We have... I think this is Z-level finish, and this is planar. Okay, so Z-level finish, zigzag cut pattern. And you can see the difference between the Z-level finish here. You've got these extra moves over here as it comes in. The advanced Z-level finish follows right along the edge that you've selected and steps down to the bottom surface. And you can see a really good step over as it goes across there. Just like the equidistant spiraling around, you have your Z-level finish following down with the same step over as it goes down the part. What's next? The advanced planar as well. Yeah, the advanced planer still has that kind of larger step over as it gets into the curved edges, the curved surface. So I really like the Z-level finish on this one. And we can backplot this here. So it looks like the Z-level finish has the same step over all the way down. But if we look at it from a top view, you can see how much smaller of a step over in this area based on the other areas, because we have more surface to cover in this curved area here. So it does a smaller step over in this area and a larger step over down to the bottom. So the option for that in the advanced Z-level finish is your adaptive depth of cut. So you can set your minimum depth step here, let's say 5 thou. You have your maximum step over as it goes across the curved surface. Let's set that to 20. And then, yeah, those are the two main options. If you turn off adaptive depth of cut, you're just typing in your depth of cut here. If you turn on adaptive depth of cut, then you have a minimum and maximum level, and you let Bobcat calculate it for you so that it goes across the surface evenly. So a few options in the finish operations as well in the 3-axis Pro to help you with the right surface finish that you're looking for. All right, so we did the single surface in the Pro. We'll do the multiple surfaces in the Pro. And yeah, just selecting the geometry as the 3D model and doing an equidistant toolpath, Z-level, advanced Z-level finish, and advanced planer. Not much to cover here necessarily, but we'll get into the advanced UI, which would be pretty good. We'll do the advanced Z-level finish, and in the advanced Z-level finish, I can change it from the standard user interface to the advanced user interface. And what that will do is it will open this new user interface. It looks just like the 3-axis premium, where you're setting your feed rate on the first page. Next page, you're setting your geometry. You're selecting your machining surfaces up at the top. I like setting the step over down at the bottom. Let's see, do we have... I'm going to do like a 1/2-inch ball and mill for the tool. And then when I go back to that advanced user interface, no, maybe let's do it in the roughing. It's a good one to show here. Z-level finish. There we go. Okay, so let's say we're roughing with a 3/4 inch. Let's do a ball and mill just for fun here, and then go to the advanced UI. Under that surface paths area, you can set your maximum step over that you want, and then you can set. Oh, it's still not here. It's in the. I know it's in the finish operation. Sorry about that. Let's go to advanced planer. It should be in that one. All right, let's do a 1/2-inch ball and mill in the advanced planer. And then we go to the advanced UI. On the first page, we're setting up the feed rate. The second page, we're setting up the machining surfaces. And then here, we can set the step over. I don't know the step over to get down to the desired tolerance level that I want to get down to. I can type it in here with my cusp height. So you can see here with this example, cusp height, some customers will call it scallop height, the certain tolerance level you want to get down to. Let's say the cusp height, I want no higher than 1 thou. I can type that in, and then you can see above that the maximum step over is calculated so that it gives us that specific cusp height. So I don't have to go into simulation, make sure everything's cut to size, and the cusp height is no larger than 1 thou in simulation. I know that it's going to be no more than 1 thou because I have Bobcat calculating it for me here in the advanced UI. A couple other options here in the advanced user interface. You can set your cutting method, zigzag back and forth. You have an undercut option. So if you're using a form cutter or a T cutter like this, you can do an undercut in roughing and in finishing operations in the advanced UI. And one other one we were going to go over in here. I don't think it was angle range, no. Trim to flute length. Yeah, I think that was it. Filtering. Yeah. I know in here in the roughing operations as well, you can set your tolerance levels, and you can also set arc fit, so it will fit an arc in any moves instead of line segments in these areas here, so that it will cut down on the G code for fitting arcs and making an arc move in the G code rather than point to point, and can cut down on the G code levels as well. All right, perfect. So David had a question in V38. Is there a setting for when you make a cam parameter change, you get the message in red on the drawing screen, need to compute toolpath? My V38 doesn't display this when I make changes. It doesn't have a message like that, but it does have an icon. If you've been looking at when I make any changes here, we'll do this 3-axis standard and 3-axis pro toolpath. I'm going to go here and change the depth of cut to 200 and change the depth of cut, change the step over to 200, we'll say. Oh yeah, you can see. So I'm on the patterns and parameters page. Two more above that, you can see that there is a red icon with an exclamation mark, and the 3-axis rough pro operation here is in red, and it says need to compute toolpath. So if I hit finish, it'll still have that icon next to the feature here, and still have that icon next to the 3-axis rough pro operation here. It wants me to hit compute so that icon goes away. But yes, if you make any changes here as well, let's change the depth of cut to 250. You can see need to compute toolpath. Something that's really cool. We went over this in the V38 new features, but we'll highlight this again. In this new interface here on the side of the screen, I can click up at the top and click Compute Toolpath, this icon up at the top. It will compute the toolpath inside of the feature that I'm working on. So I don't have to hit compute down at the bottom, let it compute and see the toolpath here. If it doesn't look good, maybe the step over doesn't look good, I can right click on the feature and edit again. That was the old process. Now you can easily, let's change the depth of cut to 225. Hit compute up at the top, it updates for me. Yeah, that doesn't look good. Let's do a depth of cut of 200. So now I can change it to 200. Hit compute. Okay, that looks fine. And then I can go on to the next page and change those settings. Click compute, so it'll compute in real time for us, so we don't have to close out of the cam wizard here, look at the toolpath, go back into it every time. Saves you time that way. David, you said you don't get that. In version 38, make sure you're in version 38 and you've got this new interface over here. It should be a setting that's set up by default. We did already come out with a new service pack. So on bobcatsupport.com, where you're at, up at the top, there's a tab for downloads. You can go to downloads and download the newest version. Make sure Bobcat version 38 is closed down. Run the newest version as a complete install. It'll update for you and check after that and see if you get that error next time. All right. So we went through the 3-axis standard, the 3-axis pro milling operations. If you guys have any more questions, please let me know in the comment section. We'll go through the 3-axis premium now. So the 3-axis premium is found by right-clicking on Machine Setup 1 and going to Mill Multi-Axis. You'll see Mill 2-axis, Mill 3-axis, Mill 4-axis rotary, and then Mill Multi-axis. It's under Mill Multi-axis because it's in 4 and 5-axis milling as well. And you'll go here and click on Mill Multi-axis. You have some options. If you don't have 4 or 5-axis milling, these will be grayed out. The wireframe in 4 and 5-axis, the multi-axis machining for roughing in 4 and 5-axis, swarf machining for 5-axis, multi-blade for impellers for 5-axis, port machining for 4 and 5-axis for porting, and turn milling for 4-axis. You're sort of turning down the stock with a milling tool. Take a look at the 3-axis milling operations in here, which include deburring. That's included in the 3-axis premium. So you can use a lollipop tool like this, or a ball end mill, or a chamfer tool to follow along any corners and break the edges on the corners of your part that you've machined. So you get a quick deburring operation with your CNC machine instead of having to do it by hand. That can save you a lot of time. Next, we get into the 3-axis premium surface-based toolpaths, which are down at the bottom here. We'll look here at parallel cuts first. Parallel cuts is where you can select single surfaces for the tool to follow down the surface or follow across the surface that you've selected. Cuts along curve. I'll do another part file because I've only got flow line in this one. We'll take a look at a second part file that I have for cuts along curve, morph between 2 curves, and some other options there. Demo files and 3 premium. There we go. So this one, I used 3-axis Pro to rough it out. I next used the cut along curve, and next page, set my work offset number. Next page, select the tool. I'm using a 375 ball end mill, and then open my parameters, just like the advanced UI in the 3-axis Pro. We've got our drive surfaces that I'm selecting to finish, my step over, and again, that cusp height option, which is really cool. You can type in exactly the kind of surface finish you want. Next page over here is the tool axis control. In 3, this is where you can control or 4 or 5-axis machining. In the 4-axis here, this is 4-axis simultaneous or 5-axis simultaneous. So it's not necessarily indexing. It can follow along these surfaces and tilt the tool normal to the surface as well. That's getting into 4 and 5-axis there. Next, we have our gauge check page. Linking for each step over. It's just going to do a direct link, step over back and forth. We do have roughing in here. You could, like for example, if you're going down into a channel, you can set the number of roughing passes, how far they're going to be spaced out, number of finish passes, and how far they're going to be spaced out. And then utility to control feed rates, rapid rates, things like that on the last page. So on the first page, your drive surfaces will be the top 2 surfaces here. And the lead curve up at the top for the cuts along curve will be this edge right here. So it's going to go perpendicular to that edge back and forth. One other thing I like in the 3-axis premium is you have this extend and trim option. So you can extend the toolpath or trim it back as far as you want. This is your tangential extensions. So if I type in 1/2 inch on both sides here, you'll see what that looks like. So here's your 1/2 inch tangential extensions past the surface. And we can see from the side view here that it follows the surface itself. It doesn't follow down the surface of this fillet. It just goes and extends tangentially across the end of the surface that we have. So that's our tangential extensions. Next we have, I'm going to just set this back to 100 thou. Next we have our side extensions. I'm going to change this to 100. Basically what that is doing is before the operation here, it'll start 100 thou and do a couple of passes before it gets to the surface selected, and then it will go past the surface 100 thousandths as well. And again, what I like about this is it doesn't dip down past the surface. If I look at it from the side here, you can see the toolpath. Here's the extra 100 thousandths that it does across the surfaces. So it doesn't follow down the curved surface, it just follows tangent to the surface going across. This is our side extensions, and then this would be the tangential extensions. All right, next one down is morph between two curves. So you select one edge that you're starting the toolpath at, selecting all the surfaces, step over all the way across to the last edge that you select of your surfaces. So with this one, again, select my tool and open the advanced user interface page. Here's my first edge curves. If you can see that in red right here, going all the way around the loop here like that. Those are my first edge curves. Here's my drive surfaces. I'm doing this morph between two curves on all of these surfaces highlighted in red. And then last one, second edge curves would be the bottom edges of those surfaces at the bottom there. You can see the step over that I have set. Also set the cusp height, trim and extend options. And all of these pages are the same for every 3-axis premium toolpath. The tool axis control, we're doing 3-axis, gouge check, linking for each step over, roughing, utility. And we can see the toolpath here. And we'll compute it. So you can see the step over here of, what did I set? 50 thou for the step over. You can see on the top here, this top radius, a larger step over, and down at the bottom, a much smaller step over to follow along this curved surface to keep the same surface finish all along the surfaces here selected. And it morphs the toolpath, right? It's not necessarily a planar toolpath. It's more like an equidistant toolpath, you could say. But it starts with the upper edge curves. That toolpath goes around those edges, and then the second edge curves, the toolpath ends at those specific edges. The equidistant doesn't have both options there. It only has the outside edges, and then it just shrinks to the center of it, of the surfaces selected. So yeah, we've got those options there. What else do we have in the premium toolpaths? We have the next one down, parallel to multiple curves. So we select the edges here in orange, and it will create an array of the toolpath outward like this. Project curves is just like the project curves in 3-axis Pro. You're projecting a 2D shape onto a 3D surface. This is also found in here for 4 and 5-axis, so the tool can stay normal to the surface as it tilts. Morph between two surfaces is just like morph between two curves, but instead of the edges of the surfaces, you're selecting the side walls of a channel like this, so that you make sure that you're not gouging along any side walls there. Parallel to surface is just like the parallel to multiple curves. You're selecting your surfaces here, and it creates an array of the toolpath outward. And flow line. That one's found in our part file that we were working on here. The flow line, I'm just selecting a single surface here as my geometry. Flow line, select the tool, and then open the advanced, tell it which direction, long ways or the short side of the surface, U or V direction, and set your step over. Also set the cutting method, zig or zigzag, 3-axis, gouge check, linking, and roughing here. And there's one other one here for flow line. So this flow line was selected with all of the surfaces here. I wouldn't do it this way. I especially wouldn't do the vertical walls here. If I were to do a finish operation with flow line, I'd probably try to trim this surface up and then follow along so that I'm not going over that step there. You can see the flow line kind of has problems there, but does really great with single surfaces, any curved surfaces like this. The flow line you can select and we'll backplot it. So you can see it starting from the top and just stepping over. Very similar to the advanced Z-level finish in the Pro for this one. All right. So that's about it for today. The Mill 3-axis Standard versus the Pro versus the premium toolpaths here. If you guys have any questions, please let me know in the comments section. David, you were saying that you're on the latest build. Let's check the build number I'm on, but it should be in there. Oops, not settings. File. Help. Yep, I'm also on build 5765 for version 38. And that is, again, that's on our website, bobcatsupport.com, to download that newest version of version 38, the newest build. If it doesn't have the cam option, I'm thinking maybe go to File and Settings. There should be a setting in here to setup sheet, display, enable, separate. I don't see it in here necessarily. Context menu, no. If you don't find something, you can always go to File. Oops. Up at the top, go to File, go to Help, and up at the top, Bobcat Cam Help. This is basically the manual to the software program, and I'm just going to search for, let's see, what's the error message that comes up when I go to Edit, and I go to change anything here in version 38. It says need to recompute or need to compute toolpath. Need to compute toolpath. I'm getting toolpath pattern. Oh, also, it just directed me to what's new in version 38. That's found in the chapters here. Up at the very top, what's new in Bobcat version 38. And that was, let's see, that's in CAM. Let's go to General. We're in Mill 2-axis, customize depths. Yeah, so if you want to see all of the new features in Bobcat V38, again, we've got a webinar for that in our library here, and you can also view all of the new features here in what's new in Bobcat V38. There's a whole lot of them in here. 3-axis, rest finishing. getting into 4-axis. So what was that error message? Need. Oh, no, I don't want to do it in the search here. I want to go Control F. Need to compute toolpath. Uh-oh. There we go. Okay. So the navigation tree here, as we call it in version 38, the navigation tree is used to quickly move through the CAM wizard, providing an easy visual of all the pages in the feature. Simply click on the icon title of the page that you want to go to, and the CAM wizard will load that page. You can blank or unblank the tool operation. Alternatively, you always want this behavior of blanking out operations and only viewing the toolpath of the current operation you are working on. You have the option for auto blank new items. This will automatically blank out operations as they get created. Then whatever toolpath operation is actively selected will be shown in the graphics area. All right. You might also notice that the navigation tree will sometimes give you a need to compute toolpath flag shown here. So this is what I'm looking at on my side. Mill 2-axis lathe wire operations will compute automatically. However, the mill 3-axis and 2-axis adaptive roughing. So that's first off, make sure you're doing a 3-axis milling operation, or if you're doing it in 2-axis, it has to be pocket and it has to be an adaptive roughing pocket operation. Will need to be computed by either pressing the compute toolpath icon up at the top or hit compute finish at the bottom when you're done. You can also control whether or not you want to see the navigation tree by showing or hiding navigation tree. Yeah, that's all I see here is, so make sure you're doing a 2-axis pocket adaptive roughing, or make sure you're doing mill 3-axis. And if you make any changes, you should be seeing this icon here. It looks like, oh, also, no, maybe not. I thought that blanked out the icon or not. No. Yeah, that's the only thing that I see as a setting for that error icon there. So if you're still having issues with that, David, let us know. We're more than happy to log in, answer any questions that you have with that need to compute toolpath icon there. And if you guys have any other questions, comments, concerns, again, you can let us know in the comments section here during our webinar live. We also have in the comments section our tech support phone number, which is 727-489-0003. And we also have our tech support email address in there, support@bobcad.com. So I don't see any other questions in the comments section today. So I want to thank everybody for viewing the webinar live on basic milling, master the essentials of CNC programming. We went through Mill 3-axis Standard, Pro, and Premium today. And our next webinar, again, it's every other Wednesday. So it's going to be December 10th, 1 o'clock p.m. Eastern Time. And thank you everyone again for viewing the live event today, and hope to see you in the next one. All right, see ya.